In previous video we saw the Miller effect, but now we will use it in common emitter amplifier. You see that in common emitter amplifier, emitter is grounded and input is given on the base terminal. So this is your model. You have just simply said that you have simply used early effect also because it was given in the question, and you have make a combination of resistors and make it in a one form like this. I guess I've represented with it with some symbol. So you have represented it and make your circuit simplifier. You inserted a bridging capacitor C mu. In MOSFET it was CGD, but here it is C mu, and here you added C pi in place of CGS. In this area you already know, it is from your circuit. You have to add this new Rx and R pi. These are the new added things here. So common emitter is a little bit of complicated. In you will use Thevenin techniques here to battle out them. So midband analysis is easy. Just remove capacitors, apply KCL here, and you get the relation of K. In MOSFET it was V naught by VGS. Here it is just V naught by V pi. Coming back on our main circuit. So you see, first you will apply Thevenin on this area. You see these both resistors are in parallel, and apply a voltage divider here. See, you will replace them in model, but for also calculate C1 and C2. C1 is C mu 1 minus K. K value is this, and put K value here also. You get relation of C1 and C2 here. So replace these R Thevenin and V Thevenin in our circuit, C1 and C2. So in next step you will find R Thevenin 2. So here we have all find R Thevenin 2. Same, these resistors are in parallel, and apply a voltage divider. So a more reduced circuit will be this. This R sig pi is R Thevenin 2, and V Thevenin 2 is your V sig pi. It is easy. Just you have to apply voltage dividers and add resistor in parallels. So if I zoom in this, you get this simplified circuit. So now after finding C1 and C2, you will use this model. Add capacitor here and add capacitor here. Apply KCL here. Apply KCL, you get this equation. But don't forget to apply Laplace on capacitor. You have to apply. You have to find V naught by V pi. So your first pole is 1 by SC1 or your first pole is this SC1 RL pi. So in order to find pole next pole 1 by tau 1, simply you can see here both the capacitors both the capacitor here add up in parallel and multiply with R, because tau is RC and omega is 1 by tau. So omega is 1. If I write here, tau is RC. So in order to find pole, you have to do this. So omega is 1 by tau. Just simple, you have to do this to get your next pole frequency. Moving on to the third slide. I guess it was it. You have found it both pole 1 and pole 2. It was easy. So it is same like MOSFET, just you have to include Thevenin. Just you have to include Thevenin in it, and rest is simple. Not too much complicated. Just you have to apply Thevenin very carefully and get this modified circuit which I am pointing final which I have written finalized circuit, and just apply KCL at one point and voltage divider at another point. I guess you will get your pole frequency. It is 1 divided by C1 RL by, and in next it is 1 by R6 C pi plus C1. So this Miller concept holds a big place here, because when bridging capacitor comes, so it is very much important to use Miller theorem. And always know that Miller is for high frequency circuit. Miller is used for high frequency circuit. We will see that in low frequency circuit, you will see that other techniques are used. We will discuss. Okay.